Perhaps it's a reflection of the types of games that I like to play and make, but roads and paths are so integrated into the everyday human experience that it's not surprising to me that we also find them in our virtual worlds as well. Whether it's a simulation game, a racing game, city builder, or action-adventure game, somewhere along the way, you're probably going to stumble across either a path or a road. And so paths and roads are something I often find myself wanting to implement in games I design. Sometimes we want to place roads and paths simply for building out an environment for a level, and other times we may want to build a full-fledged feature and have the player place roads themselves. In previous projects, I'd often rely on a tile-based solution, which is often pretty simple to work with. There are usually a fixed number of tile types, and we can quite easily build rule sets around which tiles can snap together, and so it's a very puzzle piece-like process with limited tooling requirements. But if you want to do something a bit more complex and are perhaps building out a more realistic environment with paths and roads that need to curve and wind in more unique organic ways, well, there are some additional problems that you'll need to be able to solve. Most notably for me, this was always a question of how to handle intersections. In my early research on the topic, I found a lot of resources about spline-based roads, but most of the solutions I found would result in either cyclical loops with no junctions or branching splines that would be extruded in a super basic way that created utterly impractical intersections. Thankfully though, I think I've finally figured them out. Hi there, I'm Matt and welcome to Game Dev Guide, and in this video we're going to look at how we can procedurally generate a mesh to draw a branching road or path network complete with intersections. We're going to use Unity's new spline tool to map out the data for our road layouts, which we'll then build a mesh out of using our own custom script. Then we'll use some custom editor tooling to create junction data and procedurally construct intersections between them. And finally, we'll look at the new URP Decal projector features to decorate our road network. So, by the end of this video, we should have a pretty powerful road layout tool that we can use directly inside the editor to draw out and procedurally generate road and intersection meshes for our environments. Before we get started, this video is sponsored by Unity, as they wanted me to let you know that the 2022 LTS is now available for download. Aside from the various performance improvements and optimizations, some of the coolest changes I'm excited about with this new LTS are the two features that we'll be exploring in this video, the spline tools and updates to the decal rendering in URP, so stay tuned. There also seem to be some really neat improvements to the HD render pipeline with this release too, including volumetric materials, cloud layers, and most impressively, a powerful new water system. I think you'll agree that these are some things that Unity has quite desperately needed for a while now, so better late than never, I guess. Perhaps I'll have to find some time to explore these in the future and build out a project in HDRP. Anyway, I'll post a link below to the blog post which goes into detail outlining the full list of new changes and features. Thanks again to Unity for reaching out. So I was originally going to show off a super basic spline system for this video, but after some experimenting with Unity's new spline tool, I discovered it's actually pretty great and has a solid set of features that we can take advantage of. So I was kind of worried that I'd have nothing to talk about. However, as is the case with most Unity packages, it does only get you so far. For instance, the extrusion script is pretty limited. Basically, this script creates a polygon of a given number of sides and extrudes it like a tube around your spline, which is useful for things like ropes, vines, or anything else tubular in nature, but not really great for roads. It's also worth pointing out that our spline profile is a fixed radius and rotation, so we can't really adjust this shape much, nor do we have any control over its UV mapping, which also isn't great. Additionally, while the tool supports branches in splines, the way that the package handles connecting up the splines at these knots is fairly simplistic, which leaves us with a lot of overlapping geometry. So we end up with some rather funky and extremely limited edges at the intersections. And so this is where my further research kicked in. See, I was curious how most open world games handled this, so I went out and found a number of technical talks from various studios. And, Houdini. The answer most of the time always pointed to Houdini. And Houdini, while I will eventually conquer you one day, today is unfortunately not that day. So I kept digging and eventually found this absolutely outstanding retrospective of Burnout Paradise, which for anyone interested in open world design, I highly suggest watching. I'll leave a link down below to it, as well as some of the other resources I found useful during my research. One major takeaway for me from this Burnout Paradise talk was that they used splines to map out the streets, but rather than branch out the spline and magically create these intersections, they simply just used one spline per street and built the intersections afterwards, connecting up the splines. It's so simple. So that's the approach we're going to use here. We'll use the spline tool as our basic data structure for each road, but we'll handle the extrusion of the road and generation of intersections ourselves. With that in mind, let's get started. I have a pretty basic URP scene here in Unity 2022 LTS. It's just a plane and a simple skybox that I created. First things first, we'll go ahead and grab the splines package from the package manager. Let's also generate the project files for our packages in C#. There's a lot of stuff in the splines package, so doing this will allow us to filter through it in Visual Studio and browse through its classes more natively. If we create a new spline object and begin drawing a spline, we can see that this spline container class here is the main wrapper for our spline tool. If we jump into code and take a look at the class itself, it seems like this evaluate method should be all that we need to read data from our splines. So I've created a little class here that takes in a spline container and exposes an index and time value for us to sample. Then, using the evaluate method, we can set a position. And I've just written a little bit of gizmo code here to visualize that in our scene view. Okay, so now we can ride our little sphere around any spline we create and get the positions on our spline nice and easily. Next then, we can start writing some logic for constructing our road shape. I want to be able to control the width of our road, so we'll need to extend out from a given point on our spline. This is actually pretty simple to do, as we just create a point to the left and right of the direction we're traveling along the curve. We can use the tangent from the evaluation outputs as our local forward direction, and then calculate a cross product from the up vector. We now have a measure that we can use to trace around the length of our spline, so we now just have to move around it and connect up the dots. We'll make a script that can go around the mesh and sample a number of points, and then we'll join these points up in a for loop and build out a mesh. Now we have a spline mesh. The main issue right now though is if I edit my main spline here, the mesh doesn't update. So let's sync our mesh generation to the spline. Thankfully, there's a lovely little delegate included in the spline package for this. Okay, so now one of our spline draws and updates procedurally as we move it around. But we have multiple splines here, and so ideally I'd like this script to be able to fill out the mesh for each of our splines in this container. This means we'll need to add a bit more code in our getVerts method here and iterate through all of the splines in our group. These edges shouldn't be joining up like this. Looks like we also need to update our build mesh method and account for the vertex offsets as well. There we go, each individual spline now has its own mesh. We can now build out various different groups of splines to act as each of our paths and roads. So now it's time to deal with our intersections. But how do we go about smoothly joining up these various shapes? Well, if we bring these knots close together, you may be able to notice that actually, to create an intersection mesh, we can just join up these various corners to one another and then fill the hole. The challenge then is to know which points on our spline we're trying to connect to which other points on our spline. Now it's safe to assume in this scenario that we're only ever going to want to join up the start or end point of a spline, so we can actually evaluate at either 0 or 1 on the curve. However, we don't know which of these points here are which when going into a junction. It could be either the start or the finish. Thankfully, the spline tool comes to the rescue again because knots are indexed. So we can use some editor fun to grab our selected knot point and determine where on the spline we need to sample from to build our junction. Unfortunately, this is the point where we run into something that almost always happens whenever trying to do more with Unity's tools. This spline selection class here has a very useful reference to the currently selected spline in the editor, but it's annoyingly marked as internal, so none of our default code can get a reference to it. We actually can get access to this info, but it's super hacky. With an assembly definition reference, we can write code and pretend as if we're inside of an existing assembly. So in this instance, we can create an assembly definition reference that points to our spline package and create a sneaky static class that the rest of our codebase can talk to. Now that Unity thinks that this is part of the assembly, we can actually access any internal fields and methods. So then, we can create a new struct in our class here with an almost identical format to our selection info struct and pass in its elements. And then, as this new struct is marked as public, the rest of our codebase can now access it. Like I said, super hacky. Anyway, we've now exposed which splines we have selected and can create this little overlay panel that exposes that info. And with that, we're ready to begin building our intersections. I've created a struct that will hold our data for an intersection, and so each point we select on our spline will be considered a junction. When we press this Build Junction button, the tool will pass the data for each spline and knot into our intersection and act as a container for our road tool to use. In our road script, we can use this intersection data to sample our junction edges and calculate the center point. We can then sort these points based on their direction from the center of our intersection, so our verts follow a direction. Then we just go through and wind triangles from the center point around each vert, filling in this space. And so this is pretty good. We've got some nice intersections now that will dynamically change alongside our splines. But they're kind of boring. We've got these nice curvy splines, but rough linear intersections. It'd be quite nice if we could also get some curves on these intersections too. In order to do this, we can basically build an intersection by adding a curve between each corner point of our junction. After all, a curve is as simple as lerping between these 2 points and a center point. So, we just need to grab the end point of one junction edge and the start point of another junction edge, and then define them as a pair. However, because of the way that our splines work, our neighboring edges may actually be the same point. To illustrate this, I've colored our start point red and our end point blue here on our gizmo. As you can see, due to the direction of each spline, we sometimes see a start edge and another start edge as neighbors. So we'll want to fix this. Let's store the edges of our junctions in a struct so that we can make sure that we connect the left and right points together correctly. When setting up our junction edges, all we need to do is figure out whether they're pointing inwards towards the center or not. This is actually quite simple to figure out because if the spline point is in an index of 0, we know that the spline is facing away from our junction. Now we have nice alternating edge points and can rely on connecting our red points up to our blue points. Like before, we'll also make sure to sort our junctions so they're always ordered in a direction around the center. We'll create a new Bezier curve by sampling the left point of our previous junction and the right point of this current one. We'll then create the middle control point for our curve by sampling the middle point between our 2 edge points, and then moving the result of that towards the center of our intersection. Then, we just evaluate our Bezier curve over a given number of steps to create a series of points for our curved edge. And we can just use the same method as before to join all our vertices up, looping around them and winding our triangles from the center point. Now, we have curved intersections. The only issue here is that each intersection edge is curved, and, well, it'd be pretty great if we could uniquely control the curve node on each edge. In our intersection, let's create a new list for our curve strength. We'll use this value to control the power of our lerp. In the overlay we've built, we can expose these values in a slider from 1 to 0. So 0 will mean we end up with a straight corner, and 1 a fully curved corner. Alright, we're very nearly there now, but I've noticed that we got some weird quirks if our junctions are a bit off. So let's maybe add some additional weighting to the curve center point. We can actually get most of the way there by offsetting our midpoint here, so rather than lerping from the center of our 2 points, we actually lerp from the opposite direction of our center point. So now if our slider sits in the middle here, we have a straight edge. If we move to the left, we curve in one direction, and then if we move to the right, we're curved in the opposite direction. And then we have it. We now have a full spline tool that allows us to procedurally generate a full road mesh complete with nice intersections and curved edges. At this point, we have a complete tool, but the mesh is kind of plain looking, so let's improve our visuals a little bit. I have a road texture here that I've created that I'd like to use, but our mesh currently doesn't have any UVs. I'm also going to want to texture our roads and junctions differently, so we'll need to make some adjustments to our mesh script and break out the roads and junctions into separate submeshes. Now let's get working on the UVs. If we set the UV coordinate of every segment to 0 and 1, we end up with a really squished UV that stretches based on the resolution of our mesh, and that limits us quite a lot. Similarly, if we set the UV to the position of the vertex, we end up with a tiling global texture, which is not great either. What we want is for the road UVs to dynamically map itself relative to the resolution of the curve. So while our y coordinate will map between 0 and 1, at each point on the curve, we'll add the x value of the previous point based on its distance. As you can see, doing it this way means that we procedurally generate UVs that work for our road because it's all distance based. And then for our intersections, they're mostly going to be using a plain texture, so it's actually perfectly acceptable here to just use a world space UV coordinate. With that, we now have a fully textured road network, which is pretty awesome. For some final flourishes though, let's add some decals onto our roads. Decals are an extremely useful way to add additional detail to meshes like this. In the renderer features section of our URP settings, we'll need to enable the decal renderer. And then we can use the decal projector object to place these textures into the environment. I've created a special decal texture that has a bunch of different elements inside, and so we can use the settings on our decal projector object to tile and offset the texture in whatever way we want. For the first spot here, let's add a crosswalk at the junction like so. The only issue is that our decal projector is drawing on top of everything, which doesn't look great. We kind of only want it to draw on the roads and ignore everything else. Thankfully, 2022's light layers solve this issue, but we'll need to go back into the renderer feature and enable them. Then we just make a layer for our road and assign this to both our mesh and our decal projectors. And voila, our decals are no longer projected onto our car or the rest of our environment. I've gone through and added a number of extra details across the various road parts here, and I think it really adds a lot more variety to the look of our road. So finally, let's just wrap this level up with a little bit of additional detail. I've created a few trees here, and I'd like to fill the areas alongside and around our road with them. Fortunately, the spline tool comes with some features that allow us to procedurally place geometry along the spline, which is perfect for placing these trees around our map. So we can use this instantiate component and play with the various settings to lay out our different trees, adjusting the spread and rotations. It's a massive time saver being able to place them like this, and I'm very fond of this workflow. I've also added some street lamps along our main spline here to really finish off the look of our road. So there we have it, an almost entirely procedural road network built using various spline tools and extensions. What I really love about this is how easy it is to build, edit, and adjust level layouts. Obviously, this is just a starting point, as I'm sure there's a lot more that you can do with it, depending on what the demands of your game and its environment might require. But hopefully, this initial set of tools and techniques are useful to you and something that you're able to build on in your own projects. And that's about it for today's video. If you've enjoyed it, please do give it a thumbs up and let me know your thoughts down below. If you're new to the channel, consider hitting that subscribe button, as you'll get to know when new videos go live, or if you'd like to see more from me first, consider checking out one of the suggested videos on screen now. As always, thank you very much for watching, and I will see you again next time.